Great, so today we're going to go through the information for Lesson 6-3 polar coordinates. So, of course, we know that any point can be represented as an ordered pair xy in our traditional coordinate plane. But in addition to that, every point can also be represented by an ordered pair in a different format where your first coordinate represents the distance from the origin and the second coordinate represents the angle formed by the terminal side of the angle through that point. These that I've just described are describing a radius and an angle, or r theta. So this is what polar coordinates are comprised of. The first coordinate is the radius. So if we were drawing one of our triangles on the unit circle, for instance, the hypotenuse would be the radius, and then theta would just be the angle. So just to give you several examples, if we are plotting these points here in example 1 on the polar coordinate plane, which here is an example here, the point 5, 120, we actually do the y coordinates first in polar form. So you draw 120 degrees. So in this case, I only have the 30 degrees marked off. There aren't the 45s on the unit circle, which you can draw those in. You would need those sometimes. But that means that 120 degrees is going to land me right here. This is the terminal side of the angle. So then I go back to what we call the pole. So we call it that instead of the origin, but it's in the same spot as what the origin would be. And since the 5 is positive, that means I'm going to go 5 spaces out on that terminal side. So 1, 2, 3, 4, 5. So right here, this would be the point 5, 120 degrees. Now notice that B very strategically is negative 5, 120 degrees, which starts out the same way. I graph to 120 degrees, I go to the pole, but then when I have a negative value for my R, that means that instead of plotting the point on the terminal side, I actually go 180 degrees in the opposite direction. So when I have negative 5, that means instead of counting out on where the terminal side would be, I go the opposite way and I go 1, 2, 3, 4, 5. So this would be the point that represents negative 5, 120 degrees. If I want to do this next one, which is 3 negative pi over 6, again we do the angle first, so negative pi over 6 is negative 30 degrees. So that would land me here. Go back to the pole, and then since it's a positive 3, 1, 2, 3, my point would be right here. So this would be 3 negative pi over 6. 2, 0 degrees. Well, 0 degrees, of course, lands right here. This is its terminal side. So when I go to its pole here and then count 2 forward on that terminal side, I would end up right here. So this one looks just the same as it would have looked if we were in the rectangular coordinate plane. Last one, 0 pi over 4. So pi over 4, again, I don't have the 45s on this particular polar coordinate plane, but I know that it's going to be halfway between the 30 and the 60. So I go to where I hit pi over 4, and I go back to the pole for my starting point, and because it's a 0, that means I'm actually going to land just right there on the pole. And so that would be my point 0 pi over 4. So another thing that we need to be able to do is to find equivalent points in polar form, which is what example 2 does. So first thing it wants us to do is to graph the point 5 pi over 6. So 5 pi over 6 lands here as an angle, and then 5, so 1, 2, 3, 4, 5 spots out on the terminal side. So this is 5 pi over 6. Now it wants us to find another representation, also in polar form it says, where r is bigger than 0, but the theta is between 2 pi and 4 pi. So essentially what this is asking us to do here, since we want the radius to be positive, that means it really needs to be the same. So I have to keep r the same at 5, but I now want my angle to be between 2 pi and 4 pi. So this is just the same as asking for a positive coterminal angle. So that means I'm just going to go an entire another rotation around the circle and land in the same spot. So I'm going to do 2 pi radians more, which when I add 2 pi in this case, it's like adding 12 pi over 6 because 12 pi over 6 is 2 pi. So I'm taking my 5 pi over 6, I'm adding a full rotation or 2 pi to that, and so then that's going to give me 17 pi over 6. So my radius is bigger than 0, my angle is between 2 pi and 4 pi, and so this would actually land in the exact same spot as my original point that I was given. B, it wants my radius to be less than 0, so it needs to be negative, and it wants my angle to be between 0 and 2 pi. So I need a positive angle but a negative radius to land in the same spot, which means that in order to use a negative radius, that I actually need my angle to land 180 degrees opposite of where my original angle landed. So that means I need my angle to land here on this terminal side. So if I'm expressing where I can land there between 0 and 2 pi, I'm pi over 6 short of 2 pi. So that's going to be 11 pi over 6 is going to be the angle, the theta. And then because I don't want to land over here, I want to land in the same spot, that's going to make my radius negative 5. All right, last one. The radius needs to be positive, but this time we want our angle to be negative. So that means I want to land in the same spot as the original did. So I'm going to land there, but I'm going to get there in a negative direction. So I'm going to get here, but through this rotation, because between 0 and negative 2 pi. So in this case, that would be negative 7 pi over 6. Oops. It's my angle. And then my radius, then since I'm landing in the same spot, would be 5. All right, next thing that is up is converting between rectangular coordinates and polar coordinates, so going back and forth between them. So there's a couple different ways that you can do this. So converting from rectangular to polar, you can use these formulas that are right here. So I can just simply say this is my x, this is my y, and I could do r equals 4 squared plus 4 squared in this case, so 16 plus 16, which would be the square root of 32, which is 4 radical 2. And then I could do theta equals inverse tangent of 4 over 4. So where the tangent is 1 is essentially what we're asking for here, which the tangent is going to be 1 at 45 degrees, and it doesn't, I didn't put it in the directions here, but the book's directions do say to list them in radians. So don't write 45 degrees here, write pi over 4, because that's what the book does. So that is one way that I could get my rectangular coordinate into polar coordinates here. So this would be my radius, this would be my theta. The other way that you can do it is actually to just draw it as it would be in the rectangular coordinate plane and use that to help you figure out the radius and the theta. So in this case, if I drew it this way, this is the y, this is the x, so this is my theta, I actually can typically recognize whether I have a 30-60-90 or a 45-45-90 triangle, which we don't always have one of those two things, but if we do, they're pretty easy to recognize. So when I look at this, I see that this leg is radical 3 times this leg, which means that this is the hypotenuse. It has to be double the short leg, and the angle across from the short leg is going to have to be a 30-degree angle, which means the 30-degree angle that's in quadrant 2, if we're talking in radians, would be 5 pi over 6, and my radius is the hypotenuse. So if I just label that side, then I can actually be done. So you could have done that on A. Likewise, you can do B the same way that I did A. So I'm just giving you kind of two different options there. Doesn't matter which way you do it. If we're going the other direction, meaning we want to convert from polar coordinates back to rectangular coordinates, we're going to use what we have over here. Because we know that the cosine of the angle is going to be x over r, sine is going to be y over r, that means that x is r cosine theta and y is r sine theta. So I can say x equals r cosine theta and y equals r sine of theta. So then we can just use our unit circle or our hand trick. We know that 5 pi over 3 is a 60-degree angle, and it happens to be in quadrant 4. So at 60 degrees, our cosine is 1/2. In quadrant 4, that is positive. So I get 3 times 1/2. For the sine value at 5 pi over 3 is radical 3 over 2. And in quadrant 4, that's negative. So then that gives me as my x value, 3 times 1/2 is 3/2. And as my y value, I get negative 3 radical 3 over 2. Same thing on B, except this time they gave it to me in degrees. They also can give it to you in radians when it's not something on the unit circle. And if that's the case, then you would just use the calculator, but make sure that it's in radian mode if you're doing that, if what you're given is in radians. So here we would do x equals r cosine of 225. So 225 is the 45-degree angle in quadrant 3. Cosine is negative in quadrant 3. And 45 degrees is always radical 2 over 2. So my 2's are going to cancel, my negatives are going to cancel, and I just end up with a radical 2 for my x. For my y, r sine of theta. Again, I'm in quadrant 3, where the sine is negative also. So in this case, I actually get the exact same thing that I got for my x is also for my y. So square root of 2 for both of those. Last thing that you're going to have in the homework, and I think on the copies of the guided notes, I think that the back, somehow I must have pressed it in wrong to the calculator. So if you don't have a back, you'll just have to write this part down by hand as we go here. But converting the standard equation to polar form. So we're going to be using some of the same things that we used here when we're converting equations. So a lot of the same ideas. Namely, the most important ones are going to be that x equals r cosine theta and that y equals r sine theta. The other thing that we're going to use is actually this top one right here, but typically we'll use it in the opposite form, meaning that we will substitute r squared for x squared plus y squared and vice versa. Sorry, I have like almost no voice left. I'm trying really hard. So sorry if I sound super weird. Okay, so this is standard equation, x equals 5. Obviously, we've seen that a lot. Pretty easy equation to deal with. And so because we know that x equals r cosine theta, that's what I'm going to substitute in. So r cosine theta equals 5. Equations in polar form, we're solving for r. So in this case, we would then divide both sides by the cosine of theta, and that would be my answer. So this would be my equation, r equals 5 divided by the cosine of theta. In part B, you could do the same thing that I did in part A and substitute r cosine theta for x, r sine theta for y. But in this case, it's probably easier to use this substitution because x squared plus y squared is going to be r squared. And so if r squared is 121, then to solve for r, all I have to do is square root both sides. So I'm going to have r equals plus or minus 11 as my two different solutions for my equation. So last thing, we're converting from polar to rectangular. And I think that so far these have been not too bad. And I think that you'll find most of the homework is not terribly taxing until we get to kind of the very end. So the kind of very last thing that we're going to see here is a little bit more complicated. Now, for the r equals 6, that one isn't bad because what we can do is we can square both sides. And so if I square r, I get r squared. If I square 6, I get 36. And because if I want a rectangular form, that means I want x's and y's. So r squared, we had written over here, r squared is x squared plus y squared. So then, after I square both sides, if I make that substitution, now I do have an equation, x squared plus y squared equals 36. Now notice that it says then graph the equation. So that's the part that makes it a little tricky. This is the equation of a circle, which for most of you, you already took pre-calc, so you did circles in pre-calc, but for those of you who haven't taken a pre-calc course yet, you haven't graphed a circle since geometry. So x squared plus y squared equals r squared. So that means my center here is going to be at 0, 0. And I'm going to have a radius of 6. So if I count by 2's, let's say, center at 0, 0. And a radius of 6. So that means in all 4 of my directional areas on my quadrants, then I can draw the circle. Trying to make it actually look circular is difficult, but that's pretty close. So in order for r to equal 6 in polar coordinate form, it could be any of these points along the circle, which is why the polar coordinate plane sort of looks like a bunch of circles. Okay, next one, I've got a bunch of stuff on the bottom here. So what I would do first here is multiply both sides by the denominator. So that means that I'm going to get r times that entire thing. on the bottom, which you might think is a bad idea until you distribute, because when you distribute, then you can see what I have here are cosine theta, are sine theta. So that means this is x, this is y. So 7x plus 2y equals 6. Now, it just says to convert it to rectangular form and then graph it. This is perfectly acceptable rectangular form, the 7x plus 2y equals 6. But if you want to be able to graph it, we probably want y alone. So you don't have to write the answer in slope-intercept form if you don't want to. You could just find, for instance, both intercepts and graph it that way. But if you prefer to find it in slope-intercept form, whoa, sorry, that is so not straight. I apologize. Here, I think it's going to be easier to just plug 0 in for x to get my y-intercept, which is going to be 3. And then if I plug 0 in for y, then I get x equals 6 over 7. So the x-intercept is at 6/7. And so then that's just going to give me a graph. I'm so sorry. I'm not feeling my best, and that is terrible looking. So sorry. That's supposed to be a line. We're just going to pretend. Okay. The last one. Notice here I've got cosines and I've got sines, and sometimes we can use our trig identities to manipulate, but in this case, since I have cosines and sines, that makes it a little bit difficult. But if I have cosines and sines, I really am trying to maybe get something like what I had here, where I could have r cosine theta and r sine theta. So in this case, the way that I would be able to get that would be to multiply both sides by r. So that gives me r squared on the left, 6r cosine theta plus 4r sine theta on the right, which then allows me to make the substitution. So here and here. So I've got r squared equals 6x plus 4y. Now I can also make a substitution for r squared, because again, I don't want r's, I want x's and y's. And earlier we had said that r squared is the same as x squared plus y squared. Now, this right here is a perfectly acceptable way to write the equation. So if all the directions had asked us for was the equation, we could be done now. But it asked us to graph it. And so graphing that, I know because the x and the y are both squared that I'm going to have a circle here because I'm converting from polar form, and so a lot of times I'll get a circle. So what you learned in geometry here, and I know it's been so long, and again, if you've had pre-calc, you've done things like this more recently, but we have to do what I call double completing the square. So I need to move my x's and my y's both over here with their friends. And that gives me nothing left on the right side. But circles in general are written in this form: x minus h squared plus y minus k squared equals r squared. And so I need to have a perfect square trinomial here in order to know where the center is, and so that I can know where the radius is. So I essentially complete the square twice, once for the x and once for the y. So one blank here, which means there are two to balance out the right side of the equation. So we always do b divided by 2 squared, so negative 6 divided by 2 is negative 3, squared is 9. Here, negative 4 divided by 2 is negative 2, squared is positive 4. So that means I've got a 9 here and a 4 here, and then I just factor it. So this is a PST, x minus 3 squared. This guy, y minus 2 squared, and then I get equals 13. So You don't have to write your equation this way if you don't want. So this would be a perfectly acceptable way to write the equation, but we do need to graph it. So here now that I have it in this form, let's see if I can do a better job. Okay, that's slightly better. I have a center at 3, 2. So right 3 up 2 is where my center is. And then the radius, because this would represent r squared, so that means the radius is going to be radical 13. So you can use a calculator to get that if you want. I know that the square root of 13 is between 3 and 4 because 13 is between 9 and 16. So I would just really use that. So I'd go over 1, 2, 3 and a little more because I know I'm not quite to 4. And then same thing on all the other sides. 1, 2, 3, not quite to 4. 1, 2, 3, and then not quite to the 4 here, and then down here as well. And so then my graph would be another circle, and I'm finished. So this should give you a pretty good idea of what you're going to have in your homework. So once you've completed these notes, then you should be good to go to do the homework, which is on page 742.